Question 20. Which alcohol forms a mixture of alkenes when dehydrated? So what actually happens is when you dehydrate something using something like concentrated sulfuric acid, you remove an OH and you remove an H from a neighbouring carbon, from a carbon alongside the COH. So immediately I'm looking for something that's a secondary alcohol, so that I've got a C to the left and I've got a C to the right, so then I can remove the OH from the middle of the chain, and I can remove an H from a neighbouring carbon to the left and a neighbouring carbon to the right, and end up with the double bond that's produced at two different positions, and end up with two different structural isomers, two different position isomers. So immediately I'm looking towards B and D, and I'm looking towards the longer chain because propan-2-ol is symmetrical. So if I remove the H to the left, I'd end up with propene either way with the double bond at carbon number 1. Let me show you what I mean by propan-2-ol. So if I have propan-2-ol here, if I dehydrate this using something like concentrated sulfuric acid, I remove the OH here and I remove the H on a neighbouring carbon. So the OH and the H here, the water is removed by removing the OH here and the H here, and I'll end up with a double bond here. But because the OH is in the middle of the chain, I could quite easily remove this H to the left along with the OH and end up with a double bond here. So I could end up with pent-1-ene or pent-2-ene. If it's propan-2-ol, then because it's a very short chain, then essentially I'd be making the double bond to the left or the double bond to the right on a 3-carbon chain. I'd end up with propene either way. So my answer is answer D. Which compound has the highest boiling point? So immediately I'm looking for something that's got hydrogen bonding. And here I've found it, hydrogen bonded to an oxygen, a nitrogen or a fluorine. It's answer D. So I've got hydrogen bonding in this propanoic acid because I've got an oxygen bonded to a hydrogen. I could equally be looking for a fluorine bonded to a hydrogen or a nitrogen bonded to a hydrogen. This fluorine is actually bonded to a carbon here, so I'd get a polar bond, but it wouldn't be as polar as if that fluorine or fluorine and oxygen or nitrogen were bonded to a hydrogen. It wouldn't be quite as polar being bonded to the carbon because there's not quite the difference in electronegativities. So the answer is D. Which compound could not be produced by reacting 2-bromo-2-methyl butane with sodium hydroxide? So I've drawn for you here 2-bromo-2-methyl, so 2-bromo-3-methyl butane. I've drawn it here with sodium hydroxide. So what could happen with sodium hydroxide? It could replace the Br by nucleophilic substitution if I used cold water as my conditions. So I could end up with 2-hydroxy-3-methyl butane. That isn't one of my options. Yes, it is. 3-methyl butan-2-ol is another way of doing it. The OH at carbon number 2, 2-ol, and a methyl at carbon number 3. So D could be produced by using nucleophilic substitution of the Br in cold water. So D could be produced. I'm looking for something that could not be produced. And therefore all of the others have made a double bond by elimination. So how do I do elimination? So what actually happens with elimination is that it removes a hydrogen alongside the Br. So the OH minus from the sodium hydroxide removes a hydrogen from a carbon alongside the CBr. So there's my CBr. So it could be one of these hydrogens. It could be this hydrogen on carbon number 1 that's removed. When that's removed, the OH minus and that H will make water. There'll be a double bond here and the Br will be released as Br minus in the elimination reaction. It usually happens under conditions of something like warm ethanol. So I could end up with a double bond at carbon between carbon number 1 and carbon number 2. So I could end up with 3-methyl but-1-ene, the carbon to carbon double bond here at carbon number 1 and the methyl group at number 3. That's a possibility, 3-methyl but-1-ene, so I'm going to rule out B. Equally, I could remove this H to the right of the CBr and the double bond could end up here. So if that H gets removed by the OH minus in warm ethanol, conditions of warm ethanol and the Br comes off, the double bond will be at carbon number 2. So I could end up with 2-methyl-butene. I'm counting from the other way now. I'm working from the other way. 1, 2, 2-methyl and the bute at carbon number 2 as well. So in between carbon number 2 and carbon number 3. So my answer is A. A can't be formed, 2-methyl-butene. Sorry, the answer is B. Cannot be formed. So the answer is A. 2-methyl-butene, it should say answer A, cannot be formed. Answer A cannot be formed. Let's just check 2-methyl-but1-ene. It can't be formed here at carbon number 1 because that would mean that the Br being removed is in the wrong position. That's at carbon number 3. So it can only remove a hydrogen from here or here. It can't remove one of these hydrogens here. So it's answer A.